Okay, Brianna and Mary are speaking for us in their next talk. The talk was going to be from Danielle. She got held up at work, I believe. Yep. And so Brianna and Mary are talking to us about py.test. So I'll find out about that too.
Hi everyone, thanks for coming. So Danny was going to be talking about py.test and Selenium to test web pages. And I don't have any experience with that, but I do have experience with py.test. So I thought we could do something a bit fun to see how to get started with py.test if you don't have any experience with it. So just to get an idea of who we have, who's a Python developer here or has written some Python ever? Cool. Who's written some tests, does testing? Couple? Okay. Who feels like they probably should write some tests but haven't quite got around to it? Couple more. Okay. So py.test is a testing library, and it has a lot of nice stuff to make your life really easy, and it will work very well for whatever project you're doing in Python. And our approach today is basically, Mary knows Python, but she doesn't know py.test. So
actually true. I am not here faking lack of knowledge of py.test.
That's true. This is totally live, not staged at all. So it could go horribly wrong, or maybe it'll go awesomely, and next year Mary will be a py.test hacker. It's hard to say. So we thought we needed some code to write some tests for. So we picked a couple of things out of Zookeeper, just little things so that we can do it in 20 minutes. And we're going to see if we can write some tests for it in the time that we have. And so hopefully this approach will be illuminating, because as someone who's not experienced with py.test, Mary is going to have all those questions that I'm not going to think of, and so hopefully they're the same questions that you would have if you started using py.test. And if you have any other questions, just pipe up and we'll try to cover those as well.
Yeah. So this presentation is based on a style of presentation that has happened several times at the PyCon conference in the US, where Steve Holden, they give him more time than I'm being given here, or he gives himself more time, sits down for an hour and a half and says to somebody, teach me your library, except live on the screen.
Yeah, and there was supposed to be some gin, but I guess that was left off our rider.
Yeah, we don't have the alcohol. Okay.
Okay, so there's a list of heaps of stuff that if you are not experienced with testing probably won't mean very much to you. Oh, we have some water. That's pretty close. And we're only going to get into a little bit of this, but basically py.test lets you start writing tests with very little boilerplate, lets you lay out your tests however you want, and it will auto-discover them, or if you do something really wacky, you can tell it where to find them, and it will run them, and it will give you useful information about which ones have failed. You can run a selection of tests, you can give them special markings so that it's easier to group tests, and you don't have to do a whole lot of class boilerplate, which is quite common with the XUnit style of testing. For example, unit test, which is the testing module that is in the battery pack of Python. So to install py.test, which is step 0, we've already completed, you can install it with pip. You can also install it from your distro, where it'll probably be packaged as like Python-py.test. And just a note on the name, there is another library called py.test from Logilabs, which is not the same as this one, so try to not get that one. And although you install this as py.test without a dot, it will give you a command line thing to run, which is py.test. So it's a little bit confusing. I think in the future maybe everything will move to not have a dot. Okay. Now we're going to have a quick look at the code that we prepared earlier so that we have an idea of what we're testing, and we have to know what is the code doing before we can test it to figure out what kind of test would be useful. So this first one, ticket percentage text, is that okay to read? Is the colours okay?
Just as background, this is the Python code that runs the conference registration system and scheduling system for this conference. Except it's tens of thousands of lines of code, and this is a sample.
Is this contrast okay, or can maybe put the lights down? Would that help?
Do you want me to put white? Is white background probably easier? I'll just try white. White.
Okay, we'll stick with that. So this is a function that's taking one variable or one parameter and then an optional flag, and it looks like it's returning a string. So there's 5 different code paths. So although it's very simple, if we were going to be super diligent, we'd have 5 tests to hit each of the different options in the E4 else branches. So any questions about this code? Does anyone want to?
White words in there that have been lost now that we should know about?
No, I don't think so.
Oh really? I thought there were some white ones that are now gone.
I can try. The white ones turned black.
Yeah, cool. Okay, so let's go to our command line. And let's just do ls and see what we've got. So we've got, that was ticket.py we were just looking at. So let's make a tests directory. And then let's just touch a init file in there so that Python knows how that works. Yep. And then let's open up a file in there, and so we'll start the file name with the word test, and it will know that it's a test file, so we can just call it test all or test.
Test ticket.py.
Yep, great. Okay, so we're going to import the thing that we're going to test.
Test, I believe, ticket. Okay.
Yep, and we'll import py as well because we're going to need that in a little bit.
Like that?
Yep. And let's write our first test. So you can make your tests, arrange them as methods on classes if you want, but you don't have to, and so let's not do that because we just have a function. So to know that a function is a test, its name just has to start with test as well. So test underscore ticket.
Sorry, I'll make this one white as well. There we go, test underscore ticket.
Yep, and we don't need to pass it anything. And so then let's just call the function in ticket. So
ticket percentage text.
Well, we'll probably have to pass it something, maybe
100.
Yep, that looks good. And let's just print out that output. Cool, and save that and go back to our command line. And so let's do py.test, and we'll just see what happens. Collected 0 items, that's not so good.
Do I need an init in this directory as well?
I didn't think so.
I think you do. I think we had problems
Maybe?
having it in that directory.
Okay, maybe feed it we'll do py.test and then put tests as the name of the directory. No? Okay, let's look at our test code again.
Alright. So there's nothing else special about this file name, like the underscore, or
Nope.
it's not supposed to be anything like that, for example. Just check. I'll run the thing directly. Test ticket.
Don't underscore it.
No module called ticket.
Import Python as well.
No, it shouldn't.
Just yeah. That's,
Oh, there we go. Something happened.
What's that?
Oh.
Yeah, that was me running the tests file directly.
Oh, no, that's not a problem.
Yep.
Let's do py.test -- collect only. Oh, no hyphen.
Oh, right. Yeah, I see. Yeah.
Okay, let's put the path to the whole file.
Collect only.
Oh, not just without collect only.
test.
Oh, I think that file I think needs underscore. So
Right,
let's
okay.
move that to underscore. Sorry.
So test. Okay.
Awesome. Okay.
All right.
So we ran one test and it passed. Let's run py.test with -v so we can see a bit more about what it's doing. Cool. So it found our test and it passed. And if we do dash, let's try the -- collect only again. So collect only is not running anything, it's just telling you what it can potentially run. And so that's useful if you are trying to select a subset of tests and you want to make sure you got the right subset. And so we got -v, now let's run it with -vs. So the S flag, that did not, oh there we go. So we got some extra output this time, it's printed out, all tickets gone. It's all, just hasn't got a new line, so it's a bit hard to see. So that's the output that we got when we did that print there. And so -s is saying print anything that went to standard out even though the test passed. Normally if the test passes, it just discards anything that was printed out along the way. So let's, instead of printing this out, let's change it to an assert. So we want to assert that the result from that is all tickets gone, I think, with a full stop.
Oops.
So we can just...
Actually, it can be nice to write a failing test first, just to see if
Oh yeah, okay.
all tickets.
So, yep, so we have a failure. It's given us this information about what is wrong, and so you can get the output here in a few different ways. So if you run that again with --tb equals native, so TB for traceback. So this is an option that gives you the output in different ways, and so this is the default Python way of showing you this assertion exception. And so you can see that the thing that it's doing is giving you color and that's all it's doing in this case, but it's a little bit nicer. Another option is --tb equals short, which I quite like, although in that case it's the same, and there's tb equals long and tb equals line. Okay, so let's go and fix that.
Okay, all tickets gone, full stop.
Awesome, okay. Now let's try and hit some of those other code paths. So one option is to pass our flag early bird equals true or false. So let's make a totally separate test for this, and you can put multiple asserts in a single test, but then you can have the problem that if one assert fails, the other asserts that you've got in there may be completely unrelated, and it may be useful to know that they're still passing, or they might be failing as well. So if you can, like, these are testing two separate pieces of functionality, it is actually nicer to have them as separate tests.
It's just reminding you what the original code looks like. When % is 100, we in fact should get all tickets gone in either case, whether early bird is true or false.
That's right.
Okay, so we hopefully now have two tests that pass.
Okay, and if we just do -v?
Yep.
Great. Now, we have a good number of, as I said, we've got 5 different code paths here, and there's a couple of other things we might want to check. We might want to check what happens if you pass it a number that's not an integer. So if you pass it 4.39, does it say 4.39% tickets sold? If you pass it more than 100, what happens? Probably nothing good.
Let's check that.
Yeah, so, but instead of having 6 different tests, what we can actually do is create a parameterized test. So is there a question?
No, I was going to ask you why you didn't do that in the first place.
Okay, well, we do the simple thing first, and then we abstract it away a little bit.
I'm just testing this. What happens if the conference is more than sold out?
Yeah.
Right. It in fact prints almost all tickets gone. I mean, so something bad has happened. It was just my data to stick in there to find out what actually happened. Probably you don't actually want almost all tickets gone in this case, but that's a bug in the actual code.
Well, that's a good point. Say someone's filed a bug and they've said, when I call this with 101, it has the wrong message.
Yeah.
So what we could do is write a test to demonstrate that. So that's what we have here.
Sure. would be me.
Except in this case, what we really do, instead of asserting the incorrect but current behaviour, what it would be much nicer to do is assert what it should be, and then we mark this test as something called xfail, which means expected to fail. And so this is actually...
How to do that. So say it should be something like...
probably all tickets gone still.
Yeah.
They're like super gone.
Yeah.
Okay, so this is what it should be like, but until the bug gets fixed, this test is not going to pass. But of course, we don't want to add the test if it's not going to pass, so we mark it as an xfail. So what we do is, above the def line, we put the decorator, so the @ symbol, py.test.mark xfail, sorry.
Xfail, like that?
Yep, that's it.
All right.
Okay, so let's run our tests again and see what happens there. Great, so in the summary we've got 2 passed, 1 x failed, so it records it separately. It's not a passing test, but it's also not a failing test. So if you have stuff like continuous integration or Jenkins where you run all the tests, having x failing tests is not going to stop your build from going on or whatever, because it's expected that it fails. And so if it actually started passing, that would actually be a problem, because something needs to be updated.
Yes.
Another thing we can do...
Actually, well, it's worth demonstrating then what happens if this is an expected failure and we put the actual almost all tickets gone. What happens if an expected failure passes? It's red.
It's red, yeah, it's bad.
Yeah.
It doesn't print anything out because it passed. It doesn't have anything like a failing assertion to print out, but that will hold up your build.
Yeah. For people who aren't into the unit testing way of thinking, they have a big thing about red and green. As like, all green is your reward colour, and red is, your hurtful colour that you should try and get off your screen as quickly as possible.
If we run this again without -v, I think this shows up as an X, yeah. So you can see that something's up that you need to look at.
Yeah, alright.
So another thing that is useful in PyTest is, say we want to link this in a semi-automatic way to an issue that was raised in our bug tracker. So we can just add arbitrary, it's kind of like tags to our tests. So we use the decorator syntax, so we just do py.test.mark and just say issue 300.
Space issue or?
No, just dot.
Issue 300.
So we do this at work all the time. We use Mantis, and so people file Mantises in the bug tracker, and then we go and write tests, and it's just Mantis whatever. And so then that's actually a really easy way for our QA team to check that when we're closing bugs that they actually do have corresponding tests. So if we go back to the command line, we can actually... with -k, we can start to run just a selection of the tests. So let's do -k space issue 300. Yep, and if you did -v, you'd see that it's the same test. And so it's not running the other 2 tests because we've told it just run whatever has this, whatever matches this thing. And so that'll match either the marks like that we put then, or if you could also do this by doing -k overselling, and then it would match the test name. Okay, so let's leave that x-failing one separately, but for our test that we do expect to pass, let's do something a bit trickier and parameterize it. So this is such a simple example that it's almost trivial, but basically we only have 3 things. We have 2 things. You have the input and then you have the expected output. And so you're doing the same thing in each test, so you want a really succinct way of describing that. And so with PyTest, you can use the similar things like PyTest mark parameterize. Yep, and so first we will pass a tuple of what we're going to call these variables. So we might call them percent early bird expected. Yep, and then the second thing will be a list of the values that we want to feed into our test. And so let's just do 1 to start with, and we can use 100 true and all tickets gone.
False.
Okay.
All tickets gone. So this now corresponds, this parameterized test now corresponds to test ticket sold out, right?
Not just yet.
No.
So we need to close our list there, and then close the
So
parameterized.
the list is closed, yep.
And so this mark has to sit directly above whatever test it's going to apply to. So, yep, we just start a new one, just test ticket or whatever.
Yep, okay.
And so what we do to connect the parameterized to the test is, instead of having no parameters, we have % early bird and expected. So in the parameterize, we listed those 3 strings, and then we make those strings our parameters into the test itself.
Right.
Does that make sense?
So this makes sense because I have Brianna's screen to look at.
Oh, sorry.
What has happened is that the decorator function, which is, this is basically Python syntax for having a function that wraps around the function that's immediately above. So if you regularly have set up and tear down kind of stuff for a programming function in Python, you write that as a decorator and just stick at setup and tear down above your function, and it will run the setup and tear down. Okay, so what the setup has done, evidently, I don't know this, but judging from Brianna's code, has made % early bird and expected available as variables. So we can say, instead of doing this, we can do ticket, call the function as before, but % is available as a variable, as is early bird and expected.
Okay, that's close, but not quite right.
Sure.
But
okay.
What we just need to do is have those things as parameters that get passed or defined in the test signature. So we need to have them after test ticket.
Right. Here?
Yep.
Right. I see. It would be cooler if it did it my way. It would. Because because this way I've had to write % early bird expected, and I've had to rewrite % early bird and expected.
Well, there could be other things in there as well, so I think it's good to be a little bit explicit.
You get them externally, but getting those parameters from somewhere else besides the internally did code and just static.
Okay, well, we'll go through a little bit more. We'll see what py.test does with this first.
Yep. Okay, so we can now comment out this. Since we now have a thing that allegedly duplicates this function.
We can leave that, it's okay.
There we go.
5 minutes, Brianna.
Okay.
Yep, all right.
Okay, so let's go and run our tests with -v again. Oh, we called it PC, that's right.
You called it PC,
I've called it PC.
%. So I'm not sure why it's not working, because I've been consistent, %, and %. Yep. Global name % is not defined, so the assert.
Oh no, you haven't saved your file.
Oh. Could be. Okay, it's got a different error. Lookup error, no factory found for function argument %. I suppose it's possible that the % is a reserved name, although I think it's unlikely. And PC. That. Oh. No factory found. Available funcargs.
Okay, so it's py.test.mark parameterize, not parameterize. So the spelling is a little
like
bit.
That?
Yep.
Yeah.
Okay. And then we try again. All right.
Okay, so we have one test, which is not surprising because we only fed it one thing, and it's passed. And to distinguish it from other tests, it's just fed those pieces of data. They've become part of the test name. So let's write a couple more so that we have something that's slightly more exciting. So now to have more tests, all we need to do is add one extra line to our parameterize.
Right.
Well, okay, yeah.
Yeah, that's replacing our other test. Okay. Again, because this is quite buggy code, we can put in -1. Should have, I don't even know. Something like that. Alright, I suspect it will not.
Oh.
Yeah. Okay.
-1% early bird sold.
Right. Okay. So how do I put an expected failure here? Can I?
That you can, but it's kind of tricky.
Right.
So that is
So I
something.
probably want to make this parameterized expected failure test.
It's kind of a separate issue, I think. So you probably would just have a separate test. Is the easiest way to do it.
Yep.
When in doubt, just fall back to a separate test. But
Let's test something more reasonable.
Yeah.
So it should be 86% early bird sold. Right.
Just double dot.
Yep. Okay, and then, all right, save the file. Okay.
Yep. So although another way that you could do this is you could just have def test blah blah blah, have a list of this test data inside your function and just iterate through it yourself and do the assert yourself inside a loop. And you can definitely do that, but the problem with that is that only counts as one test in the eyes of py.test, and once an assert fails, it'll just stop. So if for some reason your first test case fails, it's not going to try anything else in the loop. Whereas this, py.test is generating these into 3 completely separate tests as if you had written them separately. And so if one fails, in this case, it'll still run the other 2. Another advantage is that if you run them distributed, so if you have a lot of tests, it can farm tests out over different cores or different machines. And so if you have genuinely separate tests, it will break them up better because they are separated. The third thing is, there's definitely another good reason to do it that way. Oh yeah, the third thing is because these variables are becoming part of the test name, you can actually use these to run a selection of tests as well. So if you only wanted to run things to check early bird, for example, you could just run -k early bird and it would select all the tests that have early bird. It would be, in that case, like 86% early bird sold. So there's definite advantage. I mean, this is a kind of trivial example, but when you have slightly more complicated things going on, it's definitely an advantage to use parameterize to actually create, X different tests instead of just doing it all inside one test.
Do you have concluding slides?
Yes, I do.
Yes, we probably should wind up then.
Yeah, okay. So as well as marking xfail, another example that's quite useful is you can mark tests to skip if some condition is true. For example, if you have tests that are only valid on some OS or if some library is available, then you can make it check to see if that condition is true, and if it's not true, it won't even run the test. And so then you don't get the kind of spurious failures, which is quite useful. So that's a super small taste of py.test. There's mailing lists, and the developers very responsive. It's great to ask questions. Some of this is from kind of based on a more detailed talk I gave at PyCon 6 months ago in Hobart. So you can look that up if you want a heap more detail than we've given here today. And thanks so much to Mary for being my willing assistant. And I hope you're all inspired to take up py.test. Any questions?
Any questions? Okay.
That good?